Our next topic is empty set. Set which does not contain any element is called empty set or null set or void set. So it means that if there is a set, it does not have any element. Okay, that time we can call it empty set. Another name is null set, and one more name is void set. So any of the three names you can use to call the empty sets. It is denoted by a Greek letter phi or empty curly brackets. Okay, open and close bracket. Is it clear? So here we have an example. A equal to set of all x such that 1 less than x less than 2. X is a natural number. So what they are asking is, this is the set builder form, that is a natural number between 1 and 2. Do we have any natural number between 1 and 2? No. So there is no natural number between 1 and 2. Hence you can write A equal to phi or empty curly brackets. Next topic, finite and infinite sets. Finite, by the term itself we can understand, it's a limited, fixed number of elements. Infinite means infinite number of elements. Let's go for the definition. A set which is empty or consists of definite number of elements is called finite. That is, you can call if a set is empty, you can call it finite set. If it is having a fixed number, that is definite number of elements, you call it a finite set. Otherwise you call it infinite. Some examples are there, then you'll understand more. Okay, here we have example. As you know, we use capital letters to represent name of the set. So W equal to days of week. So we know there is only 7 days, right? So 7 days in a week. So set W is finite. Next, S is a set of solutions of equation x square minus 16 equal to 4. So can you tell me what will be the value of x? It can be 4 and negative 4. I'll write negative 4 this side. Okay. So we have 2 elements in this set, right? So again we can call it S is a finite set. G equal to points on a line. Suppose this is a line. So infinite number of points we can plot, right? That is, infinite number of points can form a line. You can say that. So set G is a infinite set. Next, equal sets. Two sets A and B are said to be equal if they have exactly same elements, and we write it as A equal to B. Otherwise the sets are said to be unequal, and we write it as A not equal to B. Here we have an example. A equal to 1 2 3 4 and B equal to 3 1 4 2. See, if the elements are scrambled here and there, no issues, but what you have to check is the number of elements, and that number of elements are same. See, here 1 we have, here also we have 1. Okay. Next, 2 is there. Yeah, here 2 is there. 3 and 4, and all done, right? So we can say that set A is equal to set B. Exercise 1.2. First question, which of the following are examples of null set? That is empty set, or you call the other name is void set. First sub question, set of odd natural numbers divisible by 2. Okay. So what do you think? Do we have any odd natural number which is divisible by 2? No. We know the elements are odd numbers are 1, 3, 5 and all, and so on, right? So we know that these numbers are not divisible by 2. So there is no odd natural numbers divisible by 2, hence it is a null set. Fine. Do you all understand how to find null set? Set of even prime numbers. Okay, we'll write the prime numbers, okay, to have more clarity. 2, then 3. Do we have any even prime number? Yes, we have 2. 2 is even prime number. 2 is the one and only one even prime number. So 2 is an even prime number, hence it is not a null set. Next, x such that x is a natural numbers, x less than 5 and x greater than 5. If I say x less than 5, what are the elements? 1, 2, 3, 4. If I say x greater than 7, 8, 9, 10. Nothing in common, right? In between these. Okay, so there is no x that is less than 5 and greater than 7. Hence it is a null set. I hope you all understood like how to find this null set, right? Okay, next. State whether the following sets are infinite or finite. Infinite, no limit. Finite, there is a limitation, fixed number, definite number of elements will be there. Set of months of a year. How many months are there? 12. Will it exceed? No. So, it is a finite set. There are 12 months in a year. Now see here. 1, 2, 3. Can you name this set? Set of natural number. Yeah. So, see, it's going on and on and on. So, infinite set. There are infinite number of natural numbers. Here we have 1, 2, 3. The third sub question. 99, 100. It stops, right? After 100, there is no number. So, number is between 1 and 100. So, it's limited. The number of elements are 100, right? Here in this set. So, we call it a finite set. Fine. Okay, I hope you all understood this, right? Okay. Set of positive integers which are greater than 100. From where it starts then? 101, 102, 103, so on and on and on. So, you can say that infinite set. It does not stop, right? Okay. The set of prime numbers which is less than 99. Obviously, it is finite set. We know what all are prime numbers. 2, 3. Obviously, till when we go till 99, the last prime number is 97. Okay. Any doubt? Hope no doubts. It's very clear and simple. Third question. State whether the following sets are infinite. Again, same type it is. Okay. The set of lines parallel to x-axis. If this is my Cartesian system, here we have the x-axis. So, infinite number of parallel lines you can draw, right? There is no restrictions. So, infinite set. Set of letters and vowels. How many letters are there? We have only 5 letters, right? So, finite. Third sub question. Set of numbers, number multiple of 5. So, it's infinite. From where it starts? 5, 10, 15. No stop for this. We have no restriction. Okay. So, again, this is infinite set. Set of animals living on earth. Can you count the number of animals? No. So, it's unlimited. So, infinite set. The set of circles passing through origin. Set of circle passing through origin. It's infinite set again. Okay. Fourth one. In the following set given below, state whether A equal to B or not. Okay. Here we have set A, set B. Okay, we'll check the number of elements. Here 4, 4. And we'll check W. Yes. X. Here it is present. Then Y. Z. Yes. So that means A equal to B. Next. Second question. When we check, see 5, 9 is there, 13 is not there. So it is not equal. Even if one element is not there, it is not equal. A is not equal to B. Next. 4, 2, 6, 10, 8. Let's see. X such that x is a positive even integer. Positive even integer. even integer. Okay, remember that. Okay, and x is less than or equal to 10. So from where we start? 2, 4, 6, 8, 10. So equal, right? Okay, so equal to b. Next, fourth one, x equal to x such set of all x such that x is a multiple of 10. So b is 10, 15, 20. See, 15 is not multiple of 10, 25 is not multiple of 10. So a is not equal to b. Fifth question, in the following set given below, is a pair of sets equal? A equal to 3, 4, b equal to y such that y is a solution for y square plus 5y plus 6 equal to 0. So we write the given, and when we factorize, splitting middle term, any way you can tell this, we get y plus 3 and y plus 2, and the value of y is negative 3 and negative 2. So here we have 3 and 4. So a is not equal to b. I hope this is enough to understand whether set is equal or not. Our next topic is subset. Subset means, I'll read out first. A set A is said to be a subset of a set B if every element of A is also an element of B. For subset, this symbol is used to denote subset, and this is to denote implies. Okay. Symbolically, you write like this: A is a subset of B. If A belongs to A, implies A belongs to B. That is an element of A. If there is an element in A, if that same element is also in B, that time you say A is a subset of B. Okay. The symbol which you use to denote phi is a subset of every set. That is, an empty set is a subset of every set. So do not forget that. See, one more point we had. An empty set is also a finite set. And here another point we have regarding empty set is a subset of every set. Subsets of set of real numbers. Simple actually. Natural number is subset of integers, because we know that if this is natural number 1, 2 and so on and on, then for integers what do we have? Negatives, right? Negative 3, negative 2, then 1. So the elements of natural number are there in integers, set of integers. So we say that it is a subset. Okay, that is, when you say subset, the first one elements will be always present in the second set. Okay, so what all numbers are there in natural number, it is also there in integers. Is it clear? Next, set of integers is a subset of rational number. Got it? So in rational number we have negatives, right? Next, rational number is a subset of real number. We know that real number is a family of numbers, so obviously each and every number is included in R. Next, T. What is this T? It's nothing, irrational number. It denotes irrational number. So irrational number is a subset of real number. But natural number is not a subset of irrational number. Is it clear? Exercise 1.5. Make correct statement by filling subset or not subset in the blanks. So here we have 2, 3, 4 and 1, 2, 3, 4, 5. So 2 belongs to this set, 3 belongs to this set, 4 belongs to this set. So obviously subset. Next, A, B, C dash B, C, D. A does not belongs to, right, this set. So we did not check the other elements. It is not a subset. Next, X such that X is a student of class 11. Class 11 we have some students. Okay, so for example we have 25 students. Dash X such that X student of your school. So obviously this 25 students will belong to this school, right? So subset. X such that X is a circle in a plane. We don't know the size of the circle, okay? Make a note, okay? It can be of any form. Dash X such that X is a circle in the same plane with radius 1 unit. So this is some 1 unit circle, and this we don't know, it may be big or small. So what happened, we can't say that this bigger circle will belong to this set, right? If it is ulta, we can say a subset, but this is not subset, right? Next, X such that X is a triangle in a plane, and X such that X is a rectangle in a plane. This is triangle and this is rectangle. So obviously a triangle won't belong to rectangle, so not a subset. Here we have next, X such that X is an equilateral triangle in a plane. X such that X is a triangle in the same plane. So equilateral triangle can belong to a triangle, right? If I say equilateral triangle, it can belong to, this set is a family of triangles. We don't know different types of triangles are there in this set. So we can say this is a subset. Okay. Next, X such that X is an even natural number. Even natural number 2, 4 and so on. So integers means negative numbers are there. That is -3 dot. Then we have 1, 2, 3, 4. So this 2, 4 belongs to this set, right? So we can say it is a subset. Second question, examine whether the following are true or false. A, B not subset of B, C, A. A belongs to this set, B belongs to this set, but they are saying it is a not subset, so false. A and E is there, subset. X says that X is a vowel in English alphabet. So A, E, I, O, U. So A belongs to this set, E belongs to this set. So subset, true. Fine. I hope this is a easier one, right? So next topic is power of set. The collection of all subsets of a set A is called the power set of A. It is denoted by P of A, and number of elements in A equal to M, where M is the number of elements in set A, and number of P of A equal to, that is power of set A, equal to 2 raised to M. I'll explain you all how it is. That is, if we have a set, there's an example. This is a set. So collection of all subsets. So how do we write this subset of A? You write each and every element within curly brackets. So 1. So this is a subset. Then 2. Then finish. Then 1, 2. See how we write, okay, make a note. And next, as we know that empty set is always a subset of a set. So how many subset we have for set A? 1, 2, 3, 4. Okay, so here we can say that 1, that is, if it is within curly brackets, you say that it is a subset of A. Okay, but if I say only the element 1, it belongs to A. Please note the difference. Okay, did you all understand how do we write the subset of a particular set if we have the elements in such a way? So how do we write? We write each and every element within curly brackets. So 1, 2, 1, 2, 5. Is it clear? Instead of 5, you can use empty curly bracket, no problem. Okay, so how do we write the next part, like in terms of subset? So 1 within curly bracket, subset of A. But if only 1 is there, you say element of A. So here we are going to find power of set A. So how do we write power of set A? Here we have the formula 2 raised to m. Okay. How many number of elements are there? 1, 2. So 2 raised to 2 square, that is 2 square. So what is the answer? 4. And earlier when we found the subset, we got 4 subsets, right? That is 1, 2. When we write subsets in particular, in specific, you have empty set, then 1, 2, 1, 2. Is it clear? So total 4 number of subset we got it for set A. Is it clear? Okay, now I'll give one more example. A equal to 1, 2, 3. Okay, so can you tell me the power of the set? Yes, how will you write? P of A within square bracket n equal to 2 raised to 1, 2, 3. 3 elements are there. So 2 cube. So what is 2 cube? So we have 8 subset. Let's see. We'll be specific find the subset. So what are there? 1, then 2, 3, then we have 1, 2, 1, 3, next 2, 3. Then we have all together, that is 1, 2, 3. Is anything left? Yeah, the 5 is left. Got it? So we'll count 1, 2, 3, 4, 5, 6, 7, 8. We got the subset, as well as when we count, we get the power of the set. Is it clear? I hope this all understood. Third question, let A equal to 1, 2, 3, 4, 5. Here this 3 and 4 is counted as a single element. Single object, single element. Anyway you can tell. So we have here 4 elements in this set. How many elements? 4 elements. So which of the following statements are incorrect and why? Okay. So as we checked, we know this is a single element. It's an element, not a subset. It's an element, not a subset. So this is incorrect. In a correct way, if we can say that 3, 4 belongs to A. Is it clear? But not subset. Okay, now this 3, 4 belongs to A. True it is. Single element, it belongs to A. This is correct. Next, see how it is. 3, 4 is there. Again it is within curly brackets. So obviously it is a subset of A. So this is correct. Now next, 1 belongs to A. Correct. 1 is a subset of A. Incorrect. Why? If it is a subset of A, how you should write? 1 subset of A. Fine. Okay. Next, 1 to 5. Yes, 1 to 5 is a subset of A. Clear? This is correct one. Okay, 1 to 5 within curly brackets belongs to A. You can't write like this, right? Either you say 1 belongs to A, or 2 belongs to A, or 5 belongs to A. Correct. So actually 1 to 5 is, if it is within curly bracket, you call it subset. So this is incorrect. Now next we'll go for the 9th one. Okay. 5 belongs to A. Does 5 belongs to A, or 5 is a subset of A? Which one is correct? What did we learn? 5 is a subset of A, right? So this one is incorrect. Okay, what about this question? Do we need to write 5 within curly brackets? No. 5 alone is enough to write to represent the subset of A. Fine. Okay. Write down all the subsets of following sets. Question 4. First question. So what are the subset of the set? Obviously A is there. Then last but not the least, 5. So how many subsets? 2. Here we have A, then B, then both elements together, A, B. Okay, what about this one? Only alone this 5 will be there. Okay, in this case, how many elements has power set of A if A equal to 5? What is the definition for empty set? When there is no elements, right? When a set is not having any elements, you call it empty set. So no elements means number of element is 0. So we can say M equal to 0. Yes. First write the given, okay, P of A and A equal to 5. After that M equal to 0. And what is the formula for a power set of A? 2 raised to M. Write the formula. So 2 raised to M. And next step we have raised to 0, and any number to the power 0 is 1. Law of exponents, what you have learned in your junior classes. Okay, so we have one subset. Fine.